Hello. Hello, this is Mickey, and this is a continuation on the 5G training playlist. So today we're going to talk about 5G protocol stack, 5G layer 1, 2, and 3. So just a quick diagram to show about the protocol stacks. So, like we discussed before, the two side, user plane and a control plane. At the user, oops. So let me just get the pen out. So, so this is the core network, and if we're looking page on the user, the protocol stack for a user plane stack, if we will be looking based on a user plane function, so UPF, and again, these are the user plane stack. So there's like Mac, PHP, RHC, PTC, it's TAB on the UE side, and then similar it's on the Chinopi side. And so this is what that like protocols that happens in the backend that you would see. This is more like on a development point of view. You will need to know like more in details on these protocols, but for this example, we're not going to go that much in details, but we can go in the next call. So in the control plane, it's all coming from AMF. So if you actually remember yesterday, or last video, you know that AMF is where all the plane, the main function of the event. So the control plane has that's similar the protocols, but there are a few more, such as NATs. They are UE slide. And so now, since we're in control plane, we'll be looking at the UE, Chinopi, and the AMF. So AMF, it's the other side. And then here just showing this teacher control protocol stack, and this is the user protocol stack. So now let's go to 5G layer 1. So 5G layer 1, it's also known as the physical layer in the 5G network architecture. It's responsible for transmitting and receiving wireless signals over there. And if we're looking based on challenges and use cases, it will be focusing on interface management, which is talking about implementing advanced interface cancellation techniques, utilizing beamforming to migrate interface and improve signal to the noise radio. Another one would be complexity, would be a challenge. So it requires a sophisticated signal processing algorithm, and it relies on powerful hardware and optimization. Another challenge that could come is energy efficiency. As balance performance with energy consumption and adapts unique like adaptive moderation to optimize the power usage. So like we I did last time with the methods, I built it enough with all the features. So layer one features, so one would be like high data lake, which utilizes advanced moderation schemes for increased data throughput and enable multi-gigabit speed, support the bandwidth intention application. Another one would be low latency, so enables shorter transmission time for reduced latency and critical for real-time application like remote sensing and augmented reality. And there's also flexibility of waveforms, which adapt flexible waveform filter like filtering or FDM for improved efficiency and adaptivity. And commute to vision devices and users. There's also could be a massive mempo. So mempo is multiple input, multiple output. So it will implement a massive amount of that technology, and it will use multiple antennas to enhance its signal coverage and capability. For beamforming, it will leverage the beamforming technique to enforce signals directionally and enforce signal strength for specific user area or improve overall network performance. So after the layer one, there will be a layer two, which refers to the data link layer. And it's responsible for data framing, tracing, and error detection. It plays a important, like critical role managing the communication between the end device and the radio access network. So that. Then some possible like challenges that could come with legacy management. So the challenge could be that in 5G demands ultra low latency, but in the layer 2 protocol does not meet that requirement. And then a possible solution could be like implementing a new protocol like Matic Second or II 202.1 QPC that offers low latency and efficient framework forwarding. Scalability and efficiency will be again a problem. So that's a massive IoT and increased device trained layer to scalability. So the solution could be like employ network slicing to create isolated segment for different services and optimize resources utilization of the scalability. Another problem that could come is around QoS. So to ensure that the versions application receiving appropriate QoS level is shared to network. So the possible solution might be like enhancing the QoS mechanism and allowing network operators to prioritize specific traffic types dynamically. And the last challenge that could come here is around mobility management, where frequent handovers in 5G required seamless mobile management. And the solution might be implementing mobile IPv6 or a faster handover to minimize like service interruptions and handover. So some possible features around the layer 2 might be MAC, so medium access control layer. So that means affected handle of multiple users and the device simulatory. Advanced scheduling techniques for improved spectrum utilization and support for both frequency division uh, tribute and time iteration tribute mode. Another one could be around hybrid automated repeat request. So that's called HARQ improvement. So enhance the HARQ process for more reliable data transmission and faster transmission and reduce latency and critical real-time application. In the QoS definition sheet, we're looking at multiple classes of QoS towards the application need, and we're looking at more at low latency, high throughput, and improved reliability for mission critical services. And then we also have network slicing and flexibility. So data ability to create virtual network slicing for different services. Each slide optimized for specific performance characteristics. And there's also dynamic frame structure, which one is more flexible frame structure among various traffic demands, and adaptive slot configuration different from data types. There might be also enhanced multiple user member, which is similarly communicate with multiple users for using the same frequency and improve spectrum efficiency and overall network compatibility. And there's also PTCP, which is Packet Data Coverage Protocol enhancement, and it efficient compression and decompilation mechanism to reduce overhead and improve the sponsor like support to towards types of data traffic. And then there's also radio link control, which protocol advancements, which will optimize the mechanism for reordering and transmitting packets and supporting reliable data delivery across wireless link. Okay, and then now we'll move into the total level, which one talks about level 3, which is more on like making sure the connection is established, maintained, and released. In mobile management, it's seamless handovers, support like high-speed mobility, and in QoS side, ensure towards the applications are all met. And then here's again a couple challenges that could come with so this one like complexity network diversity it institutes a more like network nodes services and interaction into layer 3 and it's so that could increase compatibility and the challenge may also include the network like changing network topology challenge like a control mechanism. Another challenge might be like on latency and QoS. Those one talks about like utilize low latency, so it's in critical real time application like automated vehicles and remote Thirdly, where the communications need to happen all the time, and a QoS so towards fight towards demand. It's customized and QoS, and this is becomes a little bit complex in the layer 3 management side. So some possible solution could be network slicing, which visualize network instance to communicate to which services like actualization, and the benefit can be tailored QoS, reduce latency and optimize the resources allocation for each service types. And the solution for software defined network may be like around centralized control, which one decouplate the control plane and from the data plane and for efficient network management and also automatic activation, so real time adjustment on based on the traffic patterns enhance the scalability. Another solution might be network orchestrations, which is more on the automation, configuration, and deployment of the network resource. And it can also put to efficiency where it scales and reduce human interventions. There's edge computing, where placing computer resources closer to the end user, minimum latency, and local processing, offloading processor to edge nodes for quicker response. So for the features, there's network slicing that expands the critical network slicing flow at layer 3, and it's customize the network instance for different use cases like IoT, AR, VR, industrial automation. RIC, it's another one of protocols, which one is lateral resource control, which one RIC loads, it's managing the lateral resource efficiency and minimization of power consumption for device in idle mode. Another one can be can on a packet data coverage protocol, so header compression for reduced header and enhanced security through encryption and integration protection. And then the RLC inactive state, which it's another feature where it describes the RLC inactive state to coverage the power when it's not transmitted data, and quickly transmission to active state to minimize latency. And the last one will be mobility management. And that talks about seamless handover between call cells for uninterrupted connectivity and support high speed mobility in vehicles and trains. Yeah, and that's all for today. Thank you. If there's any questions, please put in the chat below. Thank you. And